Welcome back to BSpice. In this session, we'll focus on extended signals. So, extended signal in the sense of AIS, analog input soft, analog output soft, digital input soft, digital output soft. So these are the focus on this session. In fact, this was requested one of our BSpice member and hence uploading. Of course, in offline, I already shared my feedback in mail, but this is for the benefit of everybody. Okay, so let's get started with the details. Yes, before going into the what do you call extended signal, let us also touch upon the standard signal. So as we know, the standard signal's analog input is nothing but the continuous variable input like temperature, pressure, or flow, right? And analog output, yes, continuous variable output like control signals to valves or actuators, and digital input, binary inputs signal like switch status on and off, and digital output is a binary output signals like relay activation, which we all knew. Okay, what we need to know is about the extended signal. So extended signal in the sense of the first signal AIS, analog input soft. So what is this? So this is basically a software based analog input, often calculated or simulated rather than coming from a physical sensor. That's the point. Now we will see the each of the AIS type of signal and the description. Average temperature. This is one of the AIS signal. So this is actually calculated from multiple temperature sensor to represent zone or process temperature. So again, this is a calculated value. That's what I meant here. Then we have a simulated flow rate. This is used during testing or simulation when there is no real flow is present. This is about the simulated flow. Then we have a derived pressure. So this is again computed from upstream and downstream pressure reading. This is a derived pressure, not directly from the pressure transmitter. Okay, so this is computed from the upstream and downstream pressure readings, available pressure transmitters. Then we have a virtual level. This is the estimated tank level based on flow in, out, and time. And we have an environmental index. This is the calculated value combining the humidity, temperature, and air quality. And set point tracking, this we all know, right? So it's an internal signal that mirrors a set point for monitoring and control logic. Then we have an alarm threshold. It's a dynamic threshold computed based on process condition. Then we have an energy consumption estimate derived from motor speed, load, and runtime. So basically, this analog input soft is a software-based analog input, often calculated or simulated rather than coming from the physical sensor. So that's about the AIS. So you may have a question where these signals are used practically, right? Yes, of course, simulation and testing during the mimic real world condition without the physical sensor, and used in advanced control strategies in feed forward, model predictive control or optimization, and of course for the data aggregation, combine the multiple inputs into a single representative value, and also used in diagnostic and monitoring to track the internal system health or performance metrics. This is about the analog input soft. Now we go into analog output soft. So this is again a software generated analog output used for simulation or internal control logic. It's only changes the analog output software. So what are all the signal? Simulated valve position. See, this is used during testing to mimic valve movement without sending hardware, a signal to the hardware. We don't have to, move the valve, operate the valve. So this is used during testing to mimic the valve movement. Then we have a virtual speed set point. Internal control logic signal, internal control signal for motor speed in simulation or predictive control. Okay, this without getting the signal from the field. So then calculated flow output, derived from process model used in advanced control strategy and soft PNID. PID controller output used in logic but not sent to the field device. That is the point. Then analog threshold output. It's a dynamic value, analog value used to adjust alarm limits based on process condition. Then energy demand signal. Output from energy optimization logic, not tied to the physical actuator. Then we have a model predictive control output. This is output from the MPC algorithm. Okay, model predictive algorithm used for internal coordination. So this is about the AOS, friends. So where this AOS are used? Yes, of course, simulation and testing, wherein the mimic control output without affecting the real world devices, and advanced control, feed forward, model predictive and optimization logic, and virtual commissioning. Test control strategies before deployment. It's a virtual commissioning. Then internal logic coordination. Share the analog values between control blocks or the subsystem. So these are the usage of AOS signal. Now we go into DIS, digital input soft. Yes, it's a virtual or software based digital input such as status flags or internal logic conditions. Let's see what are all the signals. Simulated start and stop command. This is used during testing to mimic operator action without physical switches. And alarm trigger status. It's again internal logic that activates alarm based on the calculated threshold. And system mode flag. I hope you are aware of this system mode flag. This indicates whether the system is auto, manual or maintenance mode. Then we have an interlock condition met. It's a Boolean result from logic checking multiple process condition. Then virtual safety trip. Simulated trip used for testing shutdown sequences. This is actually virtual. And batch trip complete. Internal flag showing completion of batch process. This is used for batch process, especially in pharma. And communication status on-off signal indicating whether the device or a network is online. Then we have a permit to operate, logical condition that grant permission for the equipment to run. So these are some of the DIS. So again, where this DIS are used, yes, again during the simulation and testing, wherein the mimic digital input without affecting the real world devices, advanced logic control, wherein to enable the complex interlocks and condition based operations, and during virtual commissioning to validate the control strategies before deployment, and finally the diagnostics and monitoring to track the internal system states or communication health. This is about the DIS. Now we see the DOS. It's a digital output soft. Yes, it's a software driven digital output used for internal signaling or simulation. Same as digital input, but only thing is here it's an output signal. Okay, DOS. What are all the signals? Yes, simulated motor start command. This is used during testing to mimic a motor start without activating the real hardware. In this case, the field motor. Then virtual alarm acknowledge. Internal flag to simulate operator acknowledgement of an alarm. You are not doing it exactly, but to simulate the operator acknowledgement. Then batch step trigger. Software generated signal to initiate the next step in batch sequence. This is in the batch sequence. Then we have an internal reset command. It's a logical output to reset the interlock during simulation or testing. Then permit to operate signal. Again, it's the internal output used to enable or disable equipment based on logic condition. Then system mode change command. It triggers a mode change from auto to manual or manual to auto within the control system. Then test pulse output. Simulated pulse used to test logic or timing sequence without getting the exact from the field. And of course, for communication heartbeat. This is for the on-off toggle to indicate the system or network health in diagnostics. This all the DOS example. So where this DOS are used, yes, it is very much used in simulation and FAT, wherein the mimic control outputs without energizing the real world devices. Then it's used in advanced logic control also, coordinate the internal logic between control modules. Then virtual commissioning, wherein to validate the control strategies before deployment, and diagnostics and monitoring to test the system response and communication integrity. So that's all I have for this extended signal list, friends. I also planning to upload a serial AI, serial DI, serial AO, and serial DO in the next session. Stay tuned. Thank you. Take care. Bye bye.